Right, so welcome to the Connected Factory. I'm Jeremy, co-founder and CTO of the Unified Manufacturing Hub, and with me is Matthew Parris. Hi, Matthew.
Hello, good morning, good afternoon.
Good morning, good afternoon here. For me, it's 5 p.m. What is it for you? 8 a.m.?
11 a.m.
Oh, okay. It's halfway doable. So welcome to today's podcast, where we will talk about DataOps, where we talk about the CESMII. Is it pronounced correctly? CESMII?
Yeah, that's how I'd say it.
Where we talk about the CESMII API, where we talk about Matthew's real-life experiences in the field of Unified Namespace and IIoT integration. So you work at GE Appliances. What is it that you do there?
So I've been at GE Appliances about 8 years. And when I first started, I joined the test equipment group. And that's where I still am today. So in the test equipment group, we're chartered to drive the standardization of equipment that's going into the factories that evaluate the quality of the product that we're producing. So if you imagine that we're within a factory and the whole reason we're in a factory is to make something. So there's various points along the way where we have to evaluate the quality of that product that we're making. And so the checks that we do are both, we have set of checks that are 100% inline checks, and we have a set of checks that are offline audit checks, which is a X% of production. And then we have more checks that are even fuller audits or more extensive audits. So the equipment that's used to perform those checks is the purpose of our team. So we closely, one of our big stakeholders is quality, obviously. There's also operations, because our equipment has to flow within the realm of operations and not create bottlenecks, not create issues for the operations. And a lot of our equipment also integrates tightly with operators themselves. So we have to consider ergo, or we have to consider footprints, or various, making sure that they have the items that they need or the information that they need to do their jobs. So I've been in that role as a test engineer, and then moved into a position of a director for that, taking on more of standardizing across our full business, which is all of our factories. Recently, in the past year and a half, my second job still within this position is to deal with cybersecurity for all of our factories. We have a position of security for the IT side, but I'm the main focal point for the security for the equipment. So if you think of all the controls equipment within the factory, what do we need to do to create secure equipment and have that equipment work securely when it's connecting into IT as well? So that role has been pretty recent, and we're just getting into some exciting things regarding that, creating a safer environment in our factory from a cybersecurity perspective.
And I think when we last talked, I think you mentioned, because I think for people from Europe, GE Appliances might not be a household name. I think you're producing a lot of equipment like washing machines. Am I correct there?
That's right. So we deal with all the home appliances. So if you think of laundry, so you have washer machines and dryers. Mm-hmm. You have cooking, so ovens, microwaves, dishwashers. You have water heaters, so in your house to create hot water. So we do that as well. And refrigeration, so refrigerators for the kitchen as well. We have some sister companies that are part of the High Air Group located in Europe. I think in Italy, Candy is one. Another one is Fisher Paykel, which is based out of New Zealand. So that's maybe a little bit further away from y'all, but yeah, those are the big ones. So definitely some competitors for us would be Bosch, would be an appliance competitor for us, along with Electrolux. That may be another brand that's over there in Europe.
So how can I imagine it? There are like washing machines or like those big appliances that are produced then in a production line, probably going through some sort of line. And then you need to make sure that all of the equipment is 100% checked, probably against some electrical checks that nobody gets electrocuted when working with it, or maybe some flow checks that it doesn't leak. And then maybe every couple of percent, some advanced quality measurements to check if, I don't know, everything is still properly mounted together. Is that understanding correct?
Yeah, that's you've got the right frame of mind there. So there's three main categories of checks that we do. One is checks that are regulatory in nature. So mm-hmm. they're driven by either Underwriters Laboratory, UL, or for us, it's also CSA, the Canadian Safety Organization there. So those are checks that, to your point, they verify electrocution is going to be mitigated. So if we apply a very high voltage on the power conducting lines and measure the leakage relative to the chassis of the appliance, so the metal part that people would be touching, we want to make sure that that leakage is very low, on order of milliamps. So we'll do anywhere from 1200 volts to 2200 volts that we apply to it and do that check. So there's those checks. There's also ground bond, which is a very common check too. That is measuring the resistance from the wire that you would plug into your house. That's the ground safety wire, measuring the resistance from that wire to the chassis of the unit. So the idea is that, let's say you do have an electrical fault and you do have a short to the chassis, that the appliance itself is sufficiently bonded regarding the ground that ground won't get lifted to the point of the electric voltage that's being applied to it. It'll stay at earth ground, keeping the person safe. And if it stays at earth ground for long enough, it'll trip your breaker that's in your house, which is what we want to happen if there's some kind of electrical fault there. So we do those types of checks. The second type is quality checks, and that could be anything from verifying that the assembly process went correctly. So we're building these from scratch. So we're folding metal, we're painting, we're assembling motors, everything that needs to go into an appliance is happening within our facility. So we have to do checks to make sure that those things get connected correctly and that they're functional. So we'll do electrical measurements. So we'll turn a motor on, make sure that it performs as it should. So there's a list of quality checks like that. The third is value that we add to the appliance itself, which primarily is us applying the latest firmware to the appliance as it's going down the process. So we'll receive printed circuit boards from our suppliers that have a firmware of some version. And let's say that our product development team has an update. They will update their supply chain for that update, but there's a lag to when that supply chain will arrive in our factories. So we have the capability to deploy not only this firmware to our supply chain, which is upstream of our process, along with deploying to the field. So appliances that are out in the field, we can also deploy firmware updates. We also have the ability to deploy these updates to our factory so that when they release that update, the test engineer that's in charge of that equipment can select that updated version, and then production is flowing with that updated version of firmware leaving to our customers. So that's probably the most exciting piece of what we do is making that process as frictionless as possible from the GitHub release, doing GitHub actions, and then having that flow down to our equipment to the point to where our plant engineers can deploy that pretty quickly.
Okay, so how you got involved with all the IT stuff, because what you just explained was, besides the last part, is like very hardcore process engineering, test engineering, OT, operational technology. And when looking LinkedIn, sometimes I see, and probably the people listening to this as well, you're writing articles about IT/OT integration, about DHCP servers, networking, etc. So how did you land up there? How did you got interested in that?
I think it's the nature of the discipline of our team pulls us in that direction. So we have one foot in that electrical engineering discipline. So we're having to figure out how to interface with units, how to measure electricity, how to harness it, how to control it, how to design equipment that is able to be safe with electricity and do it in a manner that's efficient for our process. So that's one side of the job. But the other side of the job is more IT in nature. And it's because the product that we really produce for the business is data. So if you can imagine that, yes, we are controlling the process to do the checks, but if we didn't have any data as a result of that, you would think that we were failing at what the purpose of our equipment is. So the whole purpose of our equipment really is to provide data to the business so that not only can the manufacturing line in an automated way make the right decision about every serial number that comes down the line of whether it's good or not, but it's also so that the people within the business can also make the right decisions regarding quality. So all of our processes that our equipment does in the test equipment world produces reams of data all the time. So because we have to manage that data, how we funnel that up through the IT process makes us, I wouldn't say experts, but has us having to play in the IT world quite a bit. So we're well aware about database technologies. We're well aware of MQTT, which was a recent improvement for us. But we're well aware of how we have to integrate into the enterprise all the way up the full stack, which is the final destination, which is one major consumer of our data is what we call the Brilliant Factory interface. And that is our single portal for employees to go to see the real-time state and historical state of our manufacturing lines so that you're able to see what is a piece of equipment doing right now? What sequences is it running? You can also look up a serial number and see what was the past history of that serial number within the factory and see all the results of it and which ones passed, which ones failed. Go through, you could see trending of it. I'm interested in a very specific test, and I want to see how that test is performed across Station A, along with Station B, along with Station C. Is there any discrepancy between how those stations are performing? Is there any discrepancy between how different models of an appliance are behaving or reacting to a test compared to other ones? So all this data analysis, slicing and dicing of data, is a result of us making data available. And it's why that we have to be well aware of the IT discipline as well, and networking and not everything that goes into it.
How did you then get in contact with all the Walker-Reynolds Unified Namespace bubble? Because that's another step. So I think I understand how you landed up in IT, because I think you're quite data driven. I think this is what you just explained is what a lot of companies are trying to achieve. How do you specifically got involved with Walker-Reynolds, OPC UA, MQTT, and all of that?
So it started with me going to a Gartner conference in 2019. And this was in Orlando. And it was me going there to try to glean what are some of the trends that are happening in the market, and what are some things that we could be doing in the manufacturing space to improve our systems. That trip was very interesting because in some of the breakout sessions, I remember I went to one session that was about blockchain. So I don't know if you remember, blockchain was the latest buzzword back in 2019. But in that breakout session, I remember someone, an attendee, was asking the host, I was sent here by my CIO to figure out how I can secure my database using blockchain. And I remember thinking, I don't think you understand what you're talking about. And there was a lot of that. Most of the attendees were just there to be there, it seemed like. And the level of technical detail that they were discussing there was very superficial.
Yes.
But I was on there. What became clear to me is that we had a gap in our manufacturing equipment. We were very good about providing transactional data regarding the quality of the products, regarding the data that we were actually collecting. We're very good about propagating that up through the enterprise. What our gap is getting real-time telemetry from the equipment. So this is the things that maybe the operations or the quality department doesn't care about, because they don't care what the equipment's doing at a given time, just as long as the quality records are coming out in the way that they want to know. So I went on a mission to expose everything that we could about our equipment. So let's say that we have our equipment measuring voltage and measuring current. I want a way to see right now, what is it measuring on that IO. If it's controlling relays, I want to see those relay states. If it's running a sequence, what step of the sequence is it on right now? What time does it think it is? And that's also important, to have time that's in sync with the real world, so that when you create a record, it's, you can trust what time it ran. So all these things that you can imagine a piece of equipment can make available, we went through an effort to make it available. Our first stab at that was me going across the internet at the Gartner conference, off in a little corner, because I wasn't going to get value from the sessions, and scoring the web about what is the right interface to pick for this. So we write the software ourselves. We develop the design of the equipment ourselves. That's all in-house. So that's also what makes our team very unique. Not only are we an end user, we're also the OEM, all in one. So we design the schematics and the software, and we deliver that to the plant. So we play both sides of it. So the fact that we design the software ourselves means that we can do anything that we want. We're not tied to a specific interface. We can do any custom interface we want. We can do any standard interface we want. So, of course, there's Modbus that's available as an interface. I did come across Sparkplug, and I came across OPC UA. And so at that time, it seemed very clear that the direction that we should go is OPC UA. So we started looking, we knew that we wouldn't write from scratch, so we got an SDK to help fill in the gaps. And so we included that into our product and then connected up an aggregator OPC UA server. This product is not very common, but it's very similar to an MQTT broker in concept, except it's flipped. An MQTT broker receives connections. This aggregating broker will create connections to other servers. And then
something like Kepware.
Yeah, so it could subscribe to a Kepware, subscribe to all the data that Kepware can make available, and then make it available within its own namespace. So you can imagine that you have 5 OPC servers. You can have an aggregator broker, OPC broker, that would connect to all 5 of those and pull all that data into a single OPC namespace to then make available to some other client so that they can access all the data of the 5 servers without having to connect to the 5. So anyway, we were going through all of this. And then I started digging into this, like, what does this mean? How do we flow OPC UA data and all that? So it was February of 2020 that I came across one of his videos, which was, is OPC UA the foundation or the future of IIoT? So I came across that video on YouTube, and then that's how I got introduced to that community, was February of 2020. So at that time, he was making a lot of statements about OPC UA that were confusing to me as a user of OPC UA, such as OPC UA, you have to pay for the standards or this or that. And so I started commenting on them, asking questions, because I found that I could get the standard for free.
Really?
And then
where can you find the standard? I only know the HTML page where you can, I don't know, somehow browse through it, but you can't really read it. Yeah.
So I started commenting, we started engaging. And in fact, with the type of questions that I was asking, he thought that I was someone from the RAMI reference architecture group or was a vendor that was advocating for RAMI. And that's not the case at all. I'm just an end user trying to figure out, like, what's the right direction to go in all this confusion. And so then later that year, I joined the Discord server in December of 2020, and then started just going to, there was a really good community on the Discord and to share ideas. And I think it was in March of 2021 that I reached a level 10. I guess they have these different levels based on how much you're contributing or commenting or discussing. So then it was shortly after that I joined they had community spotlights at the time. So they would kind of pick active members and then kind of do spotlights like this. This was all in the early days of Discord. So David Schultz, previous guest on your podcast, was a community spotlight. These community members have been around for 5 years or more. So all the things that you're seeing in the market are a result of that community kind of coming together and swapping stories and sharing pain and sharing successes.
Wow. Okay. That's quite the story. So, well, so I had this whole list of questions I was going to ask you now, but I think you already answered most of them. Before we go a little bit more into the details, so you joined the group 2020, and you had the community spotlights. What was, in the past years since then, something unexpected that you learned when, I assume at one point you were also switching from OPC UA to, not switching, but you were going to use MQTT. So what was something recent that taught you something unexpected?
Yeah, so it did flip, and that's kind of the second chapter of the story is we deployed our software with OPC UA, and we had this aggregating broker, and then we had Ignition up above. So Ignition would connect to the aggregating broker, and then the aggregating broker would connect to our individual pieces of equipment. And that's how the data would flow up. And then not only that, but our equipment is very distributed in nature, meaning we'll have multiple pieces of equipment that need to connect to each other. So if you were to draw it out on a piece of paper with multiple nodes around the periphery and draw lines from one to one, it would look like a mesh or a spider web of the number of connections that are happening. So it would be our piece of equipment connecting to another piece of equipment over OPC UA. And so every piece of equipment would have to service anywhere like 50 connections coming into it, manage the production process as we do it. This all became very unwieldy to manage for our team. The SDK felt very clunky in terms to integrate it into the software, meaning like these ideas of reflection or whatnot were not intuitive. You would have to bind your things statically to it to expose variables. You couldn't just tie an attribute or a property to it and then have it automatically exposed by the OPC UA server. So there's friction there to integrate our software package into the SDK. It didn't feel very modern in terms of how the approach is to integrate with software today. More friction is, like I said, if we had to power down a piece of equipment, we would lose those connections and then power it back up, and sometimes those connections would not reestablish. So that was some difficulty with the connection management from equipment to equipment, and that would cause downtime for our production server or our production process. The most, I guess, keen friction was in integration. So if we have to add a piece of equipment, we can walk through what that process looks like. I get that piece of equipment and I provision it and it's ready to go. So now it's got a network connection and it's got an IP address and it's ready to be connected to from the aggregation broker. So I have to go to the aggregation broker, create a new instance, set up a new connection with the very specific things like host name or IP address that are tied to it, and then get that connection going. So now that data is available in the aggregation broker. Now I have to go up to Ignition. I have to go to Ignition and I have to say, I have this new piece of equipment, so I need to subscribe to that data that's in that namespace. So there's two places where for every piece of equipment that I add, I have to go do manual work. I have to go to the aggregation broker to initiate the connection, and then I have to go to Ignition to subscribe to the data. So all this was piling up. And I remember the conversation very vividly of the developers saying, we should try MQTT. And I knew that this was going to be a very big split in the road because you're moving from this very distributed point-to-point architecture to putting a single point of failure in the middle of the MQTT broker in a production environment. So if that MQTT broker goes down, it's not that we lose visibility, which would happen. It's that our production process breaks. So I remember evaluating it and we decided that we would go that direction. And I already knew at this point that MQTT is a very open, it's almost like TCP in terms of you can put anything you want into the payload. It doesn't care. So I remember we were already tied to Ignition in terms of our dashboard for visibility. And I remember thinking, well, if we're going to go MQTT, we should do Sparkplug because that's going to allow our integration to be very seamless because Ignition understands Sparkplug. So we reworked our interface and we had some downtime where we were able to flip our equipment. We left the OPC interface there in the software, but we stopped using it and we flipped over to MQTT. So we put a cluster of PCs on the plant floor and we had these RPCs connect to it. And then I had the MQTT broker bridge up to a plant-wide broker and then have Ignition subscribe to the data on the plant-wide broker. And now you can look at the integration process for this architecture. So you add a piece of equipment to the plant floor. The software already knows to connect to the broker, so that connection happens. The bridge is already there to bridge the data up, and Ignition is already subscribed to the data. So you have these pipes that are already set up, and they're just there waiting. So whenever you add a piece of equipment to the plant floor, the data just flows without having touched anything. So in fact, when we set up this system, this architecture of equipment on the plant floor, broker, servicing production, broker in the plant as an aggregating broker, and then Ignition connected to that, we had a handful, I would say 50 to 70 pieces of equipment that was doing it. Since that time, we're up to over 600 pieces of equipment that have connected without us having to touch any of that integration. The data just flows. So I haven't had to touch the dashboard to add any pieces of equipment. They just automatically show up. I haven't had to touch the bridges because they just automatically flow the data. So when you experience that level of integration where you've done the minimum you need to do, which is take a new piece of equipment, connect it into the network, and it knows to connect to this broker, and then it's hands off from that, and then everything else just works, it's quite an amazing experience compared to the friction that we had before, which is touch every point in the layer and make sure that you're accommodating for it.
So this is what you also wrote in one of your articles about the decoupling, right? That you once set up like fixed, you just called it pipelines. You just set up some pipelines from the broker, I don't know, to Ignition, or then from Ignition probably into some kind of historian database. And now you can just send data to the MQTT broker, and those new devices don't need to know what's now going to happen with it. Did I understand it correctly?
That's right. And so it's your dashboards and such are awaiting the data to show up in a way that it can understand. And as long as you keep adding equipment that meets that data standard, then it'll just work. So at the very minimum, that tech stack is Ethernet, IP, TCP, MQTT, and Sparkplug. And then we have our own model on top of that using Sparkplug data types, which represents our piece of equipment. So you could refer to it as a companion spec of sorts, but it's internal. It's just how we organize our data, so that when you develop a dashboard, you say, oh, when I reach this object, I know I can go down to this level and get the time, because the time is going to be called tag time date, for example. Or if I go down to this level, I know I should expect some IO values, and it's going to be an array of IO values, and I'll read those IO values in and display the name next to the value. So you can create your dashboards to be smart as you standardize more of the stack. And so this is one of the articles that I wrote in 2021, I believe it was, titled "How All Protocols Fail at Interoperability," or Data Access Interoperability. So in that article, I proposed a data access model to be compared or contrasted with the TCP/IP model. So we're all very familiar with the TCP/IP model, where you have,
maybe explain it.
Yeah, so it's the OSI model, which is a 7-layer model, which was released in the 80s as a way of 70s or 80s to help people communicate with one another about who's doing what. And the OSI model, I would say, is probably not as relevant today as it once was, because really the world works on the TCP/IP model. So the TCP/IP model is a very condensed version of the OSI model. So you basically have your physical layer, which is Ethernet. Then you have your Ethernet/MAC, which is that layer. Then on top of that, you have IP. On top of that, you have TCP. And above that, it's undefined. You're kind of in your application. So for what we're trying to do in industry, that's not enough. That was hard enough to even standardize to that of us as an industry or as a world. That was not easy. There was a lot of battles that had to be fought to figure out, is Ethernet even the right thing? Because at the time, you had ThickNet, you had Token Ring, you had all these different types of networks. Ethernet was not the clear winner. And so that had to get figured out. But then once it got figured out, you don't really see many people advocating for other than Ethernet/Wi-Fi. That is pretty standard. So I think that's a lesson learned of what we need to be doing in our industry as well. Too many options is not a good thing. It's another way to say it. So you go up the stack. IP, that's also pretty standard. You have IPv4 and then IPv6. So that's kind of the difference that's in the market today. But then on top of that, you have UDP or TCP. So beyond that, it's kind of an open world. And so in my article, I show that really, let's assume that stack of Ethernet, TCP, IP is just considered one layer called transport. I think we can all assume that we're going to have this available to us in factories or in the field, this condensed internet stack, let's say, of TCP IP with Ethernet. We need to standardize on top of that. So where TCP IP leaves it, they basically take what we have to do and they condense into a single layer called application. We have to do the reverse. We have to take the application layer, expand it to all the levels that we need, and then we collapse the TCP IP Ethernet into a single layer called transport. So it's kind of a reverse view of the OSI model, the stack, that we're going to focus on the application layer And we need to standardize on that to really move forward. So for example, do we use HTTP? Do we use MQTT? Do we use OPC UA TCP binary? There's lots of options out there for what to use. And I think part of the too many options is why our industry is struggling to make progress in this space.
In this article, one thing that I found was really interesting is your comparison and your approach of comparing it, because you used this type of explanation and then you said, okay, let's base on TCP IP. And then you were comparing those two protocols like OPC UA. Yeah, it goes up until you were then also introducing like information models, etc. It all goes up there. But if I understood correctly, does nothing really excels at nothing of all of those. And then there's MQTT, which excels at the application level thing, but doesn't standardize anything above it. Is that summary correct?
That's right. MQTT and OPC UA, there's a lot of people that talk about one versus the other. That conversation drives the OPC Foundation nuts because for them, OPC UA includes MQTT, which is kind of bizarre that they're basically saying that we've taken over the world. Everything is us, so just use us. But what people really mean when they're saying this is MQTT with JSON representation versus OPC UA data access client server using OPC UA TCP IP binary.
Yeah, exactly. And
well, that's a very... So that was a big mouthful.
Or XML, or if you looked once through the standard, there's so many options out there.
Right. So if you go to that article online, you can see I list all the different transports that they at least specify. There are a lot of options, but it's a mouthful to have to say all that stuff. So people and OPC UA data access TCP IP binary was the first thing that hit the market. So that's the first thing that people think of when they say OPC UA, which also drives the foundation nuts because they're like, well, we're more than this. Like we do all this other stuff. And so that's just bad marketing and bad product management on their part, that they used the umbrella term for the first product that they put out. And then they expect everyone else to forget that happened. It's ingrained. I mean, it's 20 years old. You're not going to change the market's mind about like, I associate OPC UA with client server TCP binary. So when they're comparing MQTT versus OPC UA, this is the comparison. And they are two sides of the same coin where they don't specify anything in the end result. You think you're specifying something, but really you're not. So when you're talking about interoperability, let's take the MQTT side first. So let's assume you've got Ethernet TCP IP on the stack, and then you're going to go above that MQTT. If that's where you stop, you've still got a lot that you got to figure out to create interoperability.
This is typically like the main argument from the OPC UA guys when talking about OPC UA or MQTT, to say there's MQTT, but there's a lot of it missing.
That's right. So it's because it can allow anything, and that's where I presented the data access model to make this obvious. Once you get past the transport, you have a lot of choices that you have to make up the stack. So if we go from the bottom up in the data model, the bottom is the communications layer. The layer above that is I call mappings or communications mappings. It's how you're going to use that protocol, because typically a protocol can be used in any number of ways. And you have to say that client A and client B are going to use the same, even though they're talking about the same protocol, you have to make sure that they're going to use it in the same way so that it works together as a system. So again, the communications layer at the bottom, you have the communication, and that's typically the protocol itself. So MQTT fills that void or satisfies that layer. But then the mappings on top of that is custom. It's wide open. You can use MQTT in any number of ways. You can elect to use the retain bit or not use it. You can elect to use QoS or not use it. You can elect to publish topics on a time base every second. You can elect to publish it on on exception when a value changes. You can elect how your topic structure is going to be. It could be flat, where every variable is its own topic structure, all tied to the root node. You can create it very hierarchical, where it's almost like a folder structure on your computer. All that is very wide open. It's all custom. And then then you're above in the information layer. So you have in the data model, you have the communications layer, but then on top of that is the information layer. So the first layer in the information is the encoding. How are you going to encode the data? Is it binary? What type of binary? Is it ASCII? Is it bitmaps? Is it protobuf? There's a lot of options there. So you're going to have to pick one or maybe two, but both sides of the interface are going to have to agree to that. And then there's atop the encoding is the variables. So how are you going to represent variables? That's just a structure of how you're going to interface to the encoding so that this object is a variable and it's got a name and it's got a value with it. That structure has to be created. You can't assume you get that for free. And then on top of the variables is objects. So I want to put variables of similar or relation with each other. So how do I create a system where these variables can be related so that I can derive relationship information from them? Then on top of the objects, you have finally your application that's going to make use of the information. So again, real quick, the communications layer, you get the two layers in there of the communication and the mappings. You have the information layer on top of that where you have encoding, variables, objects. And then on top of that, you finally have the application, which is the whole reason you're trying to do this. You're either producing data, you're consuming data, you're analyzing data, you're storing data, you're displaying data. All that's at the application layer, but you have to flow through this data access stack before you can get at that. So
I would even add, if I may, add another layer in between. So you're on the variables and the object level. But I think also in your article, you mentioned that you focus mostly on telemetry data. If you have something else, for example, some transactional commits, etc., then you typically need to have like a layer even on top of it, because usually the protocols, underlying protocols, they only guarantee so much. And I think we call it data contracts or application protocols. So when you have, for example, when you want to write to a PLC, for example, via MQTT, you send the message, but then you also want to know that you got like a result that it actually worked. So you kind of define via everything that you already built up. You need to also define like messages, like a protocol on top of all of those protocols. Do you know what I mean?
I do, and I'm trying to, I'm pulling up my article now to remind myself of where I put this. So I called this the data access model, kind of excluding history. And I think transactional data probably does not fit the data access model. So this is more telemetry based or telemetry focused in nature. But if we take of what you're talking about in terms of data contracts, kind of a corollary to that would be a companion spec from the OPC UA, where it's basically just how I'm going to form this item. So we can take the idea of a barcode scanner, very simple device, but I need to organize its objects in a way that other people can or other machines can just automatically understand it. So there's going to be a defined structure to that. And in my model, I was using the objects layer to be that definition, which is a sort of a data contract of when you're going to interface with me, you can rely on the data being formatted in this way so that you can assume that, oh, I'm going to hit the barcode scanner object. If I want to get the latest data, that data is going to be named this tag and it's going to be located in this place within that object namespace. So that's a little mini data contract of sorts, and how you would do that. Transactional, that's kind of a whole nother world, and that's kind of outside of the scope of what I was doing. In fact, in the article at the very beginning, I outlined the aspects of industrial Internet of Things. There's a lot of things. There's alarms and notification. There's DataOps, command and control, and historical. So all those things have to be solved as well. But my article was just in real-time data access. We're having hard enough time just in real-time data access, let alone the rest of the world that also needs standardization as well.
Yeah. So this is actually like one part where I've been spending so much time on it. Like this part where, because we're hearing it very often, unified namespace, no, you cannot do any transactional things over it. It's not designed for it. And I think you can. It's also, it's also considered best practice, but you have to kind of like rethink a lot of things that one knows. One thing in all of my articles, I always try to explain it, but I think I always got a little bit wrong. But before I go too much into it, what's your opinion on the quality of service of things? So maybe to go into this application protocol part, what's your opinion there on quality of service? I remember you once posted about the two general problem, I think, if I remember correctly. So what are your thoughts on this?
So for us, we've avoided using quality of service. So the idea is we work more in a UDP type mentality of fire and forget. And there's a couple of reasons for that, because when you start introducing quality of service, the complication of your system just starts to increment immediately. So the quality of service doesn't guarantee that your data is going to get to the intended location when you're talking about MQTT. You're only guaranteeing that it got to the first hop.
Yes.
And you have zero control over where it goes after that. So for example, you could have, again, the great thing about MQTT is that you've decoupled the two clients from each other. They have no idea how many hops are between them. You could have 500 brokers that are between client A and client B. Your quality of service that you've negotiated with broker A has no bearing about broker 1 through 50 to get to the client. So it kind of creates this false sense of security in a way. It also creates this level of statefulness that we didn't want in our systems, where we want, if we reboot or power cycle, we want it clean. We don't want to have to deal with old data that's now starting to come in. We would rather just say you're connected. The data you get in is live. And so you're going to deal with that now. That's much more intuitive to troubleshoot versus you power down, you come back up, and you get this flurry of data that's actually 5 minutes old. And you think something's happening, but it's actually not. It's in the past. So that can be very confusing for people on the plant floor, where quality of service has queued this up and now is starting to redeliver it. So that level of complication we were not interested in, because it was only going to create havoc or very unintended consequences, maybe weird results where it got a command in and starting to take action on that command, but that command was sent 10 minutes ago and the process is already done and now it's trying to do something. We wanted to avoid all that. So we stick with zero.
Okay. Give me 1 second. I think we need to cut out this part. I need to write my colleagues because some other people here in front of the door are quite loud. Can someone...
For what it's worth, I'm not hearing it.
Okay. It's very good. But so it's like a little bit difficult for me if I hear we're currently still in a shared office and you hear like champagne bottles like popping up in the background and I don't know what they're currently doing. Can someone tell those guys maybe to be a little bit more silent again? Kinda hard to concentrate with champagne bottles opening in the background. Thank you. Smiley. Okay, all right. Okay. So sorry about that. We will cut it out. Where did we leave off? What was the last thing you said?
That we stick with QoS 0.
Yeah. So this is also something that I always see it, and I get really a lot of people that just think about wrong. So when I couldn't write my article, I was even thinking about saying, okay, quality of service is a lie, but then it's also not, because if you understand exactly what it means, then it's not lying. But a lot of people are like, yeah, quality of service 1, means my message will actually arrive at my target destination. But it's like exactly what you said. There's a good kind of paper. It's called Idempotence is Not a Medical Condition, which goes really into all of the details of why it's so hard. And it doesn't matter what protocol you use. Even in OPC UA, you always need to have some kind of application protocol on top of it if you want to do some requests like this. You can work a little bit, if you have QoS 1, you can work a little bit with, how was it called? That every message is exactly formatted and such.
It's only sent once, guaranteed to be sent once or something like that.
So, and then if it arrives at the database, that you can easily deduplicate it, so that every time you, for example, you can do it with a timestamp very easily for fire and forget, because in QoS1 it can still arrive multiple times. Hard. So
I mean, this has been a struggle because TCP has itself a keep alive to make sure that the session in the socket is up, but that's not good enough. We don't trust that. So then we have MQTT, and we have a last will and testament message that can come across when that gets disconnected. And part of that is because you've added the broker in the middle. And so you can't trust your own TCP connection. You have to rely that the full end-to-end connection is working. But to your point, if you really want to know if the other side of it is alive and there, it's going to be in the application. It's going to be some kind of heartbeat or some handshaking that's happening that the other is there.
Yeah. Idempotent, like I already said it in the title of our paper, it was idempotent, that the message is idempotent. And just a technical question, do we have can we go 10 minutes more over time? Okay, all right, yeah. So, and then one thing I noticed when I was now researching on the topic of MQTT, what I think is really interesting, and I want to hear your opinion on it, is one technical reason why messages get lost. So we were also experimenting, it's already 3 or 4 years back, also with quality of services, and we always found that bridges, data was always somehow going missing. And I think I've now found the reason for it, which is MQTT's strength is also its weakness. So do you know about the 2-byte packet identifier of MQTT?
I'll just take your word for it. It's been a while since I looked at the MQTT spec itself.
Yeah. So basically, the advantage of MQTT is that it has a very, very low message overhead. And it's actually just a 2-byte packet identifier. And which means it's used to identify a single MQTT message that's in flight. So what you can do is you can store 65,000 different numbers in it. Now, what happens, QoS, you don't care about it. Like it means 65,000 messages can be in flight, but the client can just change the number to whatever he wants. The server doesn't care. It goes out, that's fine. But for QoS1, for example, you need to have this acknowledgement. And now, this is what we always had in the past. We had a mix out of QoS0 and QoS1 or 2. So basically QoS2, for the listeners, never go for it. It's almost every expert says QoS2 is impossible. So it's only talking about QoS2 and 1. If you want to look it up, 2 general's problem, it's a theoretical mathematical problem. So we always found out that there were message droppings, and what's happening is you only have 65,000 messages in flight. And sounds a lot, but if you have now a lot of QoS0 messages and then some QoS1 messages, and now you have some kind of internet disruption, you can, for example, assuming you can have 1,000 messages per second, which happens if you have a lot of telemetry data, and some of them need to be acknowledged. Then, if you have an internet connection disruption of 120 seconds, it goes up to 65,000, so 65 seconds, up until this message byte is it's full. You cannot send more of it. So, and this is the scenario where messages, where either the broker or the client will start to drop messages. Of course, you can start to really, really well implement it all and fine-tune the broker, etc. This is, at least in our experience, but the strength of MQTT, this low message overhead, was what's also causing it to lose messages in reality. And then there are even a lot of more reasons for it, where the broker might drop the messages. So yeah, you always need those type of application protocols if you want to go more for telemetry data. And with telemetry data, it can happen that just some data points are lost. But I think we talked enough about it. What I want to talk now about it is your recent proposal. So the CESMII API. So I think you're part of the working group. Is that correct?
That's correct.
Yeah. So what is it now that you're trying to solve, and how is it different from what, for example, OPC UA is doing?
So I would say the way I couch it is, you as a user of the internet, what do you do to go get data? It's pretty self-explanatory today. You open up your web browser, and you type in a web address, and you're guaranteed to get some information. There's a lot that's happening under the hood to make that happen, believe it or not. Like your computer has got to go get a DHCP address. That's a standard that was created in the early 90s. But we take it for granted that it happens. Once you have the address, then you have your gateway that you're accessing to get to the internet, to go up and out. And then you're using DNS, which was just technology created in the 80s to resolve IP addresses, so you don't have to remember a bunch of numbers. You can just type in a human readable name. And then we've agreed as a world, so let's just use HTTP with HTML in there in a document object model, so that we're all able to understand the information we're trying to get. This was all figured out in the 90s. And here we are 30 years later as an industrial manufacturing industry. If I were to ask you, go to any enterprise and try to get data, what do you do? Like, and this is a question that we can have fun trying to have you answer as a UMH. But your probably first thing is, well, do you have a API that I can connect to? Do you have maybe a device driver that I can use, like Modbus, OPC, etc.? First off, you're having to ask the question, so we're already behind. Like today with the internet, you don't ask the question, you just go do it. So we're lacking a standard as an industry that is, this is the way that you're going to get information from software in our industrial space, from software that's in the enterprise space. To me, that there's no good reason why this is a question left unanswered. And I think that there's no reason why we can't use the technologies that have already been vetted as being very successful, and us just using it in a way that's going to be good for us. So for example, if let's just say we're going to define it as HTTP, and we're going to have some kind of mappings and some methods to query for data. So if I know the ID of the data, I'm going to ask it for the latest value, last known good value, or I'm going to subscribe to that. So I want you to give me, just tell me when it changes according to some filters. Or maybe I want to see what is the last 100 values of that. Or maybe I want to browse what data do you have to offer me. Like those are some very basic functions that I think anyone should expect today, 30 years later after we've standardized the internet. I don't think that's too much to ask. So for CESMII, I think now's the time, and that we're trying to do that. So we're trying to create a very simple, streamlined API that would be the interface to go to connect a client to a server in the level of you're in the enterprise area. So we're not talking about devices, although devices could make use of it. But part of I bring this up because the use case is very important. If you're going to be successful in an interface, you need to understand what the use case is and stay laser focused on that use case. For example, the most successful interface that we've ever created, USB. Think about what kind of pain it was to connect the mouse before. You would have a mouse, you'd have a serial port, you plug it in, you got to say, oh, my mouse is on serial port 5. You'd have to go in the back of the computer, like, what's that serial port number? Oh, yeah, that one is 5. Plug it in, and then go. And in fact, Windows tried to help with this by detecting when a serial mouse was connected, and it would auto-detect that, which actually conflicts with GPS modules today, where GPS, if they send a certain string of bytes, Microsoft interprets that as a mouse being connected and starts to move the cursor. So you can go on the internet. I'll shoot you a link to that after the fact.
All right.
It's a very low-level feature in Microsoft that you have to disable. Yeah, this is where we're at. USB was very focused on, if I have a device, I want to plug it in and use it. We should have that same very narrow use case for us. I'm a client. I want to know data. I type in an IP address, and I can get the data. It should be as simple as that. So what is the minimum that's required for that? I would say the stack should be very narrow and simple and modern to today's standards. So currently, we don't have an implementation specified yet for the API, but we're circling around HTTP with JSON encoded messages. So if you just stick with that, then you got to figure out, well, what's the mechanism going to be to do the browse function and the get and all of these? You're just creating these endpoints or these functions. And that's the communications mapping that I talked about earlier. So once we have all this defined, the idea is that we should be able to create an open source explorer of sorts. So my preference would be to make a progressive web app that CESMII could host, where anybody could go to a web address, it downloads that app locally to their browser, and then they're able to use that application within a browser to connect to a local device to then browse for the data it has, subscribe, read, get history, all of that. So once we have that client, we'll be able to connect to vendors who implement this interface. And then vendors will be able to use this interface to connect to one another as well. That's currently the working group is working to get this specified by November of this year. That's the schedule for it. And I'm very excited about it because I'm fed up with having to deal with all of the lack of standardization at this level. It seems to me ridiculous. And we all have egg on our face as an industry for not having this. And I think it's about time for us to get past this hurdle so we can move on to bigger and better things.
So it's about data access in your own words, right? So the standard is designed to provide like a very simple API where anyone just going to the shop floor is just like, okay, yeah, give me some data. I can just take a look. So I wrote down there's like read, write, query, browse. So I can just get some data out of it. I can get the last 100 values out of it. I get like a big list of what data points are available. This is what the standard is supposed to do, right?
Yeah, and history too. We want it to do history. So give me either based on count or based on time frame, give me the history of a specific element, let's say. And browse, I mean, imagine that's part of the challenge today is specifically with MQTT, how do you browse what a broker has available to it? It doesn't have a mechanism today. Really, the mechanism you do is you subscribe and you look through your subscriptions to see what is available. But that may not even answer the question either, because let's say the topic is published with the retained flag of false. You won't see data until that publish comes in again.
Yes.
So again, you don't know what has come through that broker or what could be available in the broker. And that's part of what Sparkplug is trying to solve. But again, Sparkplug is dependent on MQTT only. And the way you browse the Sparkplug namespace is to subscribe to the namespace and then send a command to say, send me all the data that you have available to the devices itself. So the broker is not even aware of the knowledge. It's just a passive pass-through. So, but imagine the capability that you could have a query that says, send me all the endpoints that are of data type pump. You would get all those IDs coming back, and then you would have those, and you say, I want to subscribe to pump.power. And you're going to aggregate all that to add up the power that all your pumps are using. So that's just a very simple use case of what we want this interface to be able to facilitate.
So one thing I've just noticed when asking you the question during our discussion was, if you focus on data access, why do you have the write in there? I looked through the
we do want to provide the ability to update. So now update covers both, I'm going to change a value that you have. So let's say we're client server. So you're the server and you are the owner of the data and I'm interested in it, but I'm also interested in changing that value that you have, that I would want the ability to write that to do an update. But update also covers the fact that you don't have the data to begin with. So let's say you are a pump and you don't have a name yet. I want to be able to write pump.name equals this. So update also includes creating, it's basically the equivalent of publish in the MQTT world, is that you're creating new data to some location in the namespace.
And how would this then work together with MQTT on a level? I assume there will be like an MQTT broker, and then there will be like this API, which will be based on HTTP as far as I understood. How would this then work together?
So the best way to see how we envision this is if you go to the github.com/CESMII, CESMII/API.
I link it.
Yeah, you'll go there and scroll down the README and you'll see an image where it has in the middle, it's got a information broker in the middle, and you have the APIs all around it. So the idea is that this API is not specifying how the applications are going to use it. It's mainly is specifying the interface that two applications will send data to one another. So it has nothing to do with how you're going to set up your architecture of your business. Are you going to be pub sub type model? Are you going to be point to point? This interface has nothing to do with that. It can be used in either. But the point is that we're going to have a standard way to send any industrial information across a single connection. So if you're trying to, because today, if you try to do a read write or you try to do a subscription, you're talking two separate technologies immediately, which is already two separate endpoints that you got to account for. There's no reason why it can't be in one. You set up let's say we're going to use WebSockets just to pick one. So I'd spin up a HTTP connection using WebSockets. I can say I'm interested in this data, and then it starts coming to me. Or I send you a query, hey, I want to know what available data do you have? And you just send it to me as a query at one time. That same connection can be used for both types of data. There's nothing in the technology that precludes us from needing different endpoints for the different flavors of data, whether it be a browse of the metadata or a query of the latest known good value or a query of the history of it or a subscription. All that can come through the same pipe. The idea is you have an application that's set up to host this API. It can be a dashboard. You have a dashboard that's a client that's going to connect to a data source to just display the data. You could have a historian. You have a historian like Timebase, for example, where Timebase has all this stored data. They could expose this API to say, you connect to this API using this standard. This is how you're going to get the data out of the historian. It could be an MQTT broker, where you have an MQTT broker that creates an API on top of their broker, where the broker would need to do some additional work to store the information that it has. So even if retain flag is false, it would still store it in its own memory to be aware of it, so that when people or when clients connect to it and ask for its metadata, it has it there ready to serve it out. So there's an OPC UA server, for example, could expose this as well as an alternative to the OPC UA TCP connection. I envision that you're going to have data gateways. In reality, what you're going to have is what I'll say is the traditional devices at the bottom. These will be your Modbus, your web services, your databases, your OPC UA servers, MQTT brokers, even for that matter. Will kind of be at this layer that's very custom transports or custom information. Above that, you're going to have a level that connects to those via those custom, MQTT direct, OPC UA direct, Modbus, REST interface, SQL. It'll have to have all these drivers and connect in and aggregate that data. So not only do you satisfy the communications, but this layer is also going to have to satisfy the information transformation as well, converting a PLC register into something meaningful. So that's where you get this idea of DataOps as well. You're going to have a DataOps layer that facilitates these legacy drivers in addition to the legacy information models into a common information model. Once you flip it into this common information model, then you could use this API to move the data around. Or as a platform, you could come up with your own custom transport and custom encoding to move the data around a distributed system, but then you would still have this API on the periphery to allow external connections to happen to get at that data that you have internally.
So if I now, because like most of those changes are always like step by step, like nobody's going to throw everything away just to go all in for it. So how would this look like? So imagine like let's take your example. So you have like, as far as I remember, every station has their own MQTT broker or even cluster of MQTT brokers. You have probably some database where you store like all the results, probably some kind of like super broker for the entire line or the entire plant. How would this come in? This would be like a new microservice, but would this be then set up on each of those brokers, or how would you set it up in your own architecture to slowly start with it?
We could just pick, let's say I would have a high byte intelligence hub. I'm just going to make up an architecture here. Mm-hmm. So that has some level of communication drivers to connect down. Mm-hmm. I could have a Kepware, and maybe Kepware adds this API to its product. Although I'm not sure if that would happen. It seems Like the level of changes happening on Kepler, it's pretty solid right now. But let's stick with Intelligence Hub from HiByte. So it could include this API in its software. So where it's going to connect down to these devices, it has the DataOps engine so that it's able to create a model and is able to take this device data and put it into the model. And then let's say that I have an external client. It could be a dashboarding, maybe Grafana. And Grafana would have this API that it includes in its software. So I would have Grafana connect to HiByte using this API, and I would just immediately be able to browse the data in a way that Grafana can understand, because the encoding and all of that is going to be defined. The methods that are available of browsing the metadata or querying for a specific last known value of a data, getting the history of the data, or subscribing to the data, all that would be well defined. And so Grafana could use any one of those to produce its dashboard. So that's just a quick example of how you could start using this API. You could have Timebase that's connected to HiByte, and it would connect to HiByte over the same exact interface that Grafana is connected to. And it would say, I want to subscribe to all the data coming in, and as it comes in, I'm going to start to store it. And then you could have Grafana that actually, let's say HiByte doesn't have history, so Grafana's got to go connect to the Timebase. So it would connect to Timebase, same exact interface that it used to connect to HiByte. It would connect to Timebase and say, give me the history of element ID X that I saw over at HiByte that came through 5 seconds ago. So this is a way that it's trying to commonize the connections of all these devices.
So probably, I'm just thinking out loud, the best way to start there would probably be to have a tool that kind of like almost everyone wants to use, something
That's
like
right.
maybe Grafana or Node-RED, or I don't know, just thinking out here. And then to build up like a standard data source in Grafana for it. And then all the vendors could put this API on top of it. Yes, UMH could also do it and say, okay, look, because we are UMH, we have all this real-time data, but we also have like all the historical data. And then there would be like a need for all the vendors to actually also provide it so that they could use the Grafana data source. And once you have it, then probably it would also make sense to maybe then there's also Power BI or Tableau or whatever other dashboarding tools, maybe Tulip, that they could see then, hey, there's like, I see there are all of those, they all provide standardized interface. What if I also provide it to get the data out of it? So it would be, it's kind of like a little bit a chicken egg problem, but once you have this thing like started, I think it's really easy for all the vendors to get started.
And what I would love for this working group to provide is the equivalent of MQTT Explorer, UA Expert, Q Modbus Master, or Postman. Mm-hmm. If you're an engineer in automation, you have these tools installed on your laptop because you don't know what you're going to have to connect to get data. But this interface should have the equivalent of that. Think about Postman, how you have to go, maybe you're lucky and the thing you're trying to connect to has a Swagger. Mm-hmm. You're able to go into the Swagger page and start to manipulate the API. To me, that's still even too much integration. That's too much work. If me as the lazy engineer, I just want to get to the data, I would have an application on my computer that is similar to Postman, except it's going to automate all kinds of stuff. So I would just have a screen that says connect IP address, whatever, and click browse. And it would show me like, here's the data of the thing you just connected to. And oh, that's interesting. So let me click the button next to that one tag and say subscribe. And it would go subscribe it and kind of put that value, the latest value over in a little subscription panel. But anyway, the idea is that you can make this available, and rather than people having to download an application on their PC directly, you could host it as a progressive web app where all they have to do is go to a website. Their browser is going to cache the application locally, and then they're able to use that application locally within their ecosystem. And that will just help communicate the value of this interface that, like everybody who's used to using Swagger or Postman, you don't have to do all that manual and manipulation of the things. It's going to help make that streamlined. Or people who are used to using OPC UA or UA Expert, you won't have to connect and then do the browse and kind of dig in. It'll be able to do that also.
I think I just got a pretty good idea. So at the UMH, we also have the a historian functionality. And the historian, like we split it up into a time series database and then the tool how an OT engineer can access it, which is via a Grafana and a custom data source. And because of our how we developed our product and our product vision, we're currently only focusing on the topic of unified namespace, where we say, okay, we put all the effort into it. And like there will also be in a couple of days some videos about it. All the videos will be released before this one. Let's see what the publishing order will be. But for now, we haven't really developed that Grafana data source anymore. But the backend was always, there's like a microservice and there was like a REST call. So one thing that I could think of is at one point, it will not be this year, will probably be next year when we come back again to the topic of historian, that we could leverage this API in order to do like a Grafana data source to backend communication if we were to use it, because we would need to probably implement a lot of it anyway. And if we could then just follow this could be a good way to maybe jumpstart it a little bit, because then with that Grafana data source, okay, it would be obviously UMH branded, but you could also then take a look at the other things, but that would be maybe something one could use to jumpstart it. I'm not saying we will do it. It's just an idea ahead what we can do without much effort, for example, on our side.
And that's the goal with this API, is to keep it kind of within the rails of what most people would do with an API anyway. Mm-hmm. And we're just going to add some structure and some definition to it so that everybody can use the same thing.
Yeah, that would be good, because you have also, you're not going to use the right one, but you're going to use the browse one. Like in the UI, you want to see an historian, you want to see what tags are in there, and then you're going to read them, and you also want to read the latest 100 values. And maybe the query one, I don't know, could also be interesting to see, please give me, maybe combined with the browse one, please give me all tags with a pump too. It's typical historian functionality. So maybe this could be one thing that we could use to jumpstart it. All right, I'm looking at the time. We're already at 1 hour and 18 seconds. 1 hour and 18 minutes. So maybe you
got another 5 hours, Jeremy?
Same with David Schultz. I feel like I could talk for hours. But maybe to wrap it up, you have a lot of experience. So you're now working for like 5 years in this very specific field of IT/OT integration. So what would be some real-world advice for someone just getting started with it, some pitfalls that one should avoid?
I think the biggest one to be aware of is when you start, don't plan too big. And when you're planning, don't start too small. I think it's a very fine balance between people who want to plan the entire roadmap and then get started versus not thinking ahead and getting started. Those are two kind of sides of a coin you want to avoid. You want to thread the needle of you've thought far enough in advance, so your vector is in the right direction, but you're going to be aware that as you take each increment, you're going to learn something new, and that could tweak the direction of the vector that you go forward. So spending too much time in the planning phase, trying to create the perfect architecture that's going to accommodate all use cases, can be very discouraging, and you could not make much progress. But if you're able to have a soft architecture in mind of the direction that you're going, and then pick a very specific use case and get that done, and then show value, and then make sure you're validating your assumptions, because in the thought process and planning process, you have certain assumptions that you've made, but you want to validate that with whoever you're delivering the solution to, that it is in fact solving the problem. And so as you get those incremental wins, you'll create this momentum, and then with every increment, you start to keep building out your architecture in that direction that you've established up front.
And any tips for getting your managers on board, or anything that you might share what helps there?
I would say you got to start with solving a problem. So whatever plans you have in the back of your mind, if you're not solving a problem for the business, it's not worth your time. So you always have to think in terms of the business, how can I solve a problem? Once you start solving problems, you'll be given more political capital to start making decisions about what direction we're going to make, or what other things we should be doing, or justifying the need for a piece of infrastructure to solve more problems. So I think it always comes back to identifying a problem and figuring out the quickest way that will solve that problem in the direction of the architecture that you would like to go, is the way to put it.
All right. So really thank you for your time. It was really nice talking to you. Like I already said, I could talk for hours with you. What I will do is I will put all the links we talked about into the description here, so that you as a viewer or listener, or wherever you find this, that you can look it up. Thank you for being here. I hope you liked it as well. And for the listeners and viewers, stay tuned. Look out into the description for more materials, and see you next episode.
Thanks, Jeremy.